All right, so these are the learning objectives that we're going to cover today up to 4.6, and then I'll look at the time. If I have time, I'll go over Boolean variables and how to use decision structures in Python. Even though we have a video on it already, I can go over it again. So, what is a decision structure? Decision structure, think of it as a way for your program to branch out and go a different way or a different direction. And what that means is we're going to have a condition statement. So if that condition is true, then our program will branch out and perform some action for us. And I'll show you an example in a little bit. And we have three different types of those decisions. The first one is just simple single alternative decision. And what that means is we will only have one condition. And if that condition is true, then some action will be made. If it's not true, then that code will just be skipped. So one alternative. Then we have a dual alternative, which means that we have two alternatives, one condition, and then if that condition is true, some code will execute, and if that condition is not true, some different code will execute, where it comes from two alternatives. And then a multiple alternative decision is just you can have as many conditions as you want, and you can have as many alternatives of your code or actions that you perform, as many as you want. So this is what it looks like, the if statement. So this action will occur only if the decision is true. So as you can see here, give me 1 second, I'm sorry. Sorry about that. Okay. So as you can see here, we have our if structure. So if some condition is true, then our program will do something that's inside of this if decision structure. So only if it's true though. So right here, we have an example of when condition is true, when condition is false. And what we do with this piece of code, we declare our integer variable called number that equals 10. Then we have our decision structure. If our number is greater than 0, then something would happen. Okay, we will do something. Now, how this would go, your computer will do, it will look at this statement, it will say, okay, number equals 10, that's easy. Then it would look at your decision structure, and what it would look for specifically is the condition and see if the condition is met. And what that means, your computer will just look and say, okay, this condition is number is greater than 0. What is number? It will go right here, and it will look number equals 10. 10 is greater than 0, then this condition is true. Then perform whatever is inside of this condition. However, right here on the second half, we have our condition number less than 0. Now your computer will look at it and be like, okay, where's the number? Number equals 10. 10 is not less than 0, so this condition is false, and your computer will just skip the whole thing that's inside of it and just continue with the code after. So if the condition is true, perform whatever is inside of that condition. If the condition is false, just skip that condition as a whole. Now, relational operators, what we use to determine if there's any relationship between the two values. And you've probably seen it in your math classes before. So x greater than y, x less than y, x is greater or equal to y, and so on. The only two that you probably haven't seen are the double equal sign. It just means that you're checking if the numbers are equal to each other, and the not equal sign. Not equal sign is just you use your exclamation point and an equal sign, which will mean that you're checking if x is not equal to y. Okay, this is the dual alternative decision structures. And as you can see here, the same idea, our number equals 10. We have our if structure right here, but the only thing that we're adding is an else. And what this will do is, let's look at this one. So if our condition is true, number equals 10. If our number is is greater than 0, then some code will perform. And this is exactly what's going to happen. So this part of code will be executed and our else will be skipped because our condition is true. So we found that our condition is true, we execute this part of code, we don't care about this one. However, if our condition is false and we have our dual alternative decision structure as right here, you can see our number is -5 and we're trying to see if our number is greater than 0, which it is not. So this condition is false and this part of code gets skipped. But since we have our else, we go straight to the else and then execute whatever code is inside of the else. So it just gives your program a way to use an alternative way of performing some action. So if this is true, do this. If it's not true, do this. Pretty simple. Yeah, this is another example. So as you can see, we have our if condition, then we have some code statements. This is just your pseudocode, basically. But here's an example. So if our condition is temperature is less than 40, then we would display a little cold, display get a coat. However, if this condition is not true, which means the temperature is greater than 40 or equal to 40, we would display nice weather and sunny. Everyone good on that one? All right. Most languages will allow you to compare your strings, and remember, string is just a sequence of characters. So in this example right here, we are gonna see if the passwords match. So we declare our variables of string called password. Then we ask the user by displaying enter the password to input whatever password they want to input. And then we're trying to see if those passwords are correct. And how do we do that? We just use our decision structures again. So as you can see here, if the value that user entered in right here, password, equals to Prospero, then we display password accepted. However, if this condition is not true, if they didn't type the right password, we're going to display sorry, that is not the correct password. So this is all it does. This is mostly why you would use strings to compare, why you would use decision structures to compare if the password is right, to compare if the username is right. Whenever you type login to Facebook or something like that, this is exactly what's happening behind the screen. So it's just a bunch of code that's comparing whatever you typed into the values that they have in the database saved for you for the username that you have. You can compare, so you can compare string variable with a string variable. You can also compare a string variable with a string literal. And the difference between the string variable and string literal is that one is saved, which is our string variable. Because remember, whenever we create a new variable, it gets stored in your memory. And string literal is just a word. Whatever you type, it's not stored anywhere. It's just whenever you want to compare something really quick to just one keyword, you would use a string literal comparison. Usually you have to remember that string comparisons are case sensitive, and some languages will allow you to determine which string is greater or less than another string. And what it means is just it's gonna take how many letters or characters are in that string, and it will compare it to the amount of characters in your other string. So just for example, if you would compare May, a string May, M-A-A, M-A-Y, to, for example, October, right? You will check if it's the same. It would not be the same because the amount of characters is different. And if you were to see which one is greater, for example, you're checking if May is less than October, then this condition would be true because October has more letters in it than May. Now, nested decision structures, it's the same thing as dual decision structures. We just add more conditions in the middle. And this is a flowchart for your nested decision structure. And I know it looks a little bit too much, but it's fairly simple. You just follow the arrows. So for example, we enter here and our salary, our condition is that the salary is greater than or equal to $30,000. If it's true, then we have a different condition. How many years you worked? If your years on job is greater or equal to 2, then we follow this arrow, which says true, and then we would display you qualify for the loan. However, if our salary is less than 30, then we go with the false decision, alternative decision, and we would display you must earn at least $30,000 per year to qualify. And the same thing here, even if our salary is fine and if it's more than $30,000, but if our years on the job is less than 2, then we would follow the false and we would display you must have been on your current job for at least 2 years to qualify. So just follow the conditions. And this is what it would look like if you wanted to program your nested decision structure. And again, this is pseudocode. Each language will have its own syntax for this. But basically, we're trying to see if which grade the student got. And if our score is less than 60, then display grade is F. Else, if our score is less than 70, then display the grade is D. If our score is less than 80, display grade is C, and so on, up to displaying the grade A. Now, case structure, it's basically the same thing as doing this, but instead of having your decisions, your conditions right here, you just have case 1, as you can see here, 1, case 2, case 3, and our default case. The only thing that you need to remember about case structures is that there's always has to be a default case structure. So if you're trying to write your code and you want to have, for example, like 2 or 3 case structures, you can do that, but you have to remember that you also have to define a default case structure in case any of these are not the right ones that your user selects. All right, logical operators. So this is where the video starts, the one that I posted for you guys. What time is it? We have enough time. Logical operators. So these are used between the conditions. So whenever you want to check if multiple conditions are true or if multiple conditions are false, you would use your logical operators, and they're not that complicated. So we have AND. It checks that both conditions are true. So it's gonna check your first condition and it's gonna look at it and say and check if it's true. If it is true, then it's going to check the second condition. If that second condition is true, then it would tell you that it is true. However, if any of those conditions are false, then your whole statement will your computer will say that everything is false. Now we have our OR logical operators, then one condition only has to be true for the Boolean expression to be true. And we have not. It's just whatever you have. If you have false, not will reverse it to true. And if you have true, not will reverse it to false. And I'll show you an example here. So this is our AND example. If our temperature is less than 20 and minutes are more than 12, then display the temperature is in the danger zone. So as you can see, this is our first condition right here. This is our second condition right here. And we're combining them with our logical AND operator. So this will only be displayed, this line of code, the temperatures in the danger zone will only be displayed if your temperature is less than 20 and at the same time your minutes are greater than 12. Now with an OR example, we have if temperature is less than 20 or temperatures more than 100, then display the temperatures in the danger zone. So if our temperature was 19, this would be displayed. And at the same time, if our temperature would be 101, this would also be displayed because we have our OR operator. So only one condition has to evaluate to true. Now with the not example, literally just negates your result. So if we have if not temperature is less than 100, more than 100, sorry, then display this is below the maximum temperature. So for example, if our temperature would be 101, right, this condition would evaluate to true. However, we have our not, so this whole thing would be false. So this code will be skipped. This whole part would be skipped. However, if our temperature was, for example, 90, this condition would evaluate to false. However, we have our not, it will change it to true, and then we would display this is below the maximum temperature. Short circuit evaluation. This is what I was talking about. So with an AND operator, if your expression that's on the left side is false, then we don't have to check the second expression. If our first condition is false, we don't have to check the second one because AND operator requires both of the expression to be true. So there's no need to check the second one because no way our expression will evaluate to true since we have one false already. And the same thing works with an OR operator. So if your first condition will evaluate to true, you don't have to check the second one because for OR, we only need the one to be true. It doesn't matter if the second one is false or true because our first one is already true. Range checking. Yeah, so we have, whenever we use AND, we usually use it to find a number inside of a range. And if you want to find a number outside of a range, you would use OR. As you can see here, if X is greater than or equal to 20 and X is less than or equal to 40, then display something. The value is in the acceptable range, so inside of the range. However, with an OR, if X is smaller than the 20 or X is greater than 40, then we would display the values outside of the acceptable range. So just remember inside a range AND, for outside of the range OR. Boolean variables. So you can create Boolean variables, and those variables can only hold two values, either true or false. As you can see here, we declare a Boolean variable called isLunchtime, and we check if time is greater than 12, then set lunchtime true. If the time is less than 12, we're gonna set the lunchtime to false. So it's very simple. It just holds two values, true or false. Focus on languages. Python. So Python is really simple to work with regarding relational operators. They're all the same as in the table that I showed you before. And this is the general format of your if statement. So if you put your expression or your condition and then some code that happens. Now this is the if else statement for our dual alternative decisions. So if something, then we have our code right here. If that is not true, then we do this. So if, then you say your expression, you put the colon, and then you write your code. We can use the relational operators to compare strings, and this is what you would do. You would put the double equal sign, again, to compare if the strings are equal to each other. So we have our name1 equals Mary, name2 equals Mark, and if our name1 equals to name2, then we would print the names are the same. Else, we would print the names are not the same. So what do you guys think this piece of code will do? Will it go here or will it go here? So we have, yeah, because we have Mary and we have Mark, and what Python will do, it will take each character and it will check it with the other character. So for example, we have here name1 equals name2, so your Python will look, okay, this is name1, this is name2, we found the locations, and then it would compare the first character to the first character. So MM we're good. AA, we're good. RR, we're good. But then Y and K, those are different characters.
So
So
it goes
the
to the
whole
second one.
thing, yeah, that's why this whole thing will just be skipped because this condition is false because our variables are not the same. So it would go to the else and it would print the names are not the same. This is how you would type your logical operators in Python. This is AND, this is OR, this is NOT. So the same as these, just not capitalized. And this is how you would use your logical operators. So if x is greater or equal to 20 and x is less or equal to 40. Remember, and for inside the range or for outside the range. So the same thing, just everything is lowercase. And remember about the colon at the end. And also important part, remember about the indentation. Sometimes you have to put it yourself, and sometimes your compiler will not do it for you. So just whenever you're working on the lab and if you have some issues, just make sure that your indentation is correct because it's very important in Python. Boolean variables, same idea. Remember that we don't have to declare the type of our variable in Python. So all you do, you just put the name and you put it to whatever value you want it to have, true or false. All right, this is all I had for today.